Hello, everybody. Welcome. My name is Lynn Kronberger, and I am the Chief Development Officer here at WAMU. As a public media organization, our mission is to connect listeners and members like you to each other and around the world. Public radio works because listeners and members who value the service step up and give back. And support from listeners and members is our most reliable and important source of funding, especially right now. This book club would not be possible if we did not have your support. So if you have been enjoying these monthly virtual book clubs, please consider making a gift. You can go to www.dianerehm.org/give. We are grateful for the close to 1,000 people who registered to join us today. That's an amazing amount of people. Just so you know, this event is being recorded and streamed on Facebook. Closed caption is available. Just click the button on your screen. And now let's start the discussion with the host of our book club, Diane Rehm.
And Lynn, thank you so much, as always, for that introduction. And I want to say a big welcome to all of you to my May monthly book club. You know, when I first read about forest ecologist Suzanne Simard and her research on tree communication, I was fascinated. I knew I wanted to talk with her, so I'm pleased to have that opportunity today. Suzanne Simard's new book is titled Finding the Mother Tree, Discovering the Wisdom of the Forest. It's the story of how she came to suspect and then prove that the health of forests is dependent on a network of underground tree communication. It's also a book about a working man's world and motherhood, finding her voice, and presenting a new way for all of us to understand the complexity of nature and our role in it. And during this hour, we'll be taking your questions, and you can type them in the Q&A box at the bottom of your screen. And of course, I'll try to get to as many as we can. Suzanne Simard, welcome to you. I'm so glad to have you with us.
Diane, it's an absolute my honor to be here. Thank you for having me.
Thank you. And I wonder if you would start by telling us about your childhood and your family in British Columbia, which is where you are now. Your family has very deep roots there.
Yeah, so I grew up in just west of the Rocky Mountains in a mountain range called the Monashee Mountains. These are what we call inland rainforests. So they're like what you think of old growth forests along the west coast of North America. These are those forests, except they're a little bit inland. So there's a lot of rain. It's relatively warm for that kind of area, although it does get a lot of snow in the winter. And my family had emigrated from France, moved across Quebec, were loggers in Quebec, and eventually made it to British Columbia, thinking they were going to California, but ended up in this wilderness, basically jumping out of the train up to this here in snow and realizing, oh my God, it's not California, it's British Columbia. And they stayed there and they homesteaded along what's called the Shuswap River, and were loggers. So they were horse loggers. So my great-grandfather, my grandfather, my dad, all of his brothers, it was a horse logging family. And so they selectively logged in these temperate rainforests, just taking out the odd tree here and there. So it was a very, very light touch. It was heavy physical labor. And this is where I grew up. I grew up watching all this, being part of this as a child in these amazingly complex, beautiful, productive forests.
And in fact, you got involved in the same work very early in life.
I did. Well, I was a girl. I still am a girl, in fact. And it wasn't really an option for me as a little girl to think that I could do this, but I absolutely adored what my grandfather did and my dad, and I just wanted to be there with them. And so I watched it all and imagined what it would be like. And then I went to university eventually, wanting to be either a writer or a scientist, and learned about this field called forestry that was, a field that my whole family worked in, but I didn't know that it was actually something you could study and do. And I was among the first cohort of girls to be allowed into that faculty. They actually actively discouraged girls from going into that. They should be going to nursing or teaching. But, I was lucky enough that I squeezed my way in that first set of girls. And and I became a forester.
Well, and you mentioned something about your family taking a tree here and a tree there. That sounds very unlike what's happening now.
Absolutely. So, it was what we call selective logging. And my Grandpa Henry, they would go up, it was way up on the mountains where they take the horses, and he built everything by hand, by the way. He built these flumes that went down to the lake. The horses were huge 2,000-pound horses that dragged these logs to the flumes, sent them down into Mabel Lake, and then they were, boomed and then sent down the river, what we call the chucks. But yes, going back to so my grandpa they would go up to the forest every day, and he would say, okay, we're going to cut down this tree. And there'd be like, the whole crew would take 2 or maybe sometimes 2 days to cut down a tree. They were big trees, but, so it was only like 1 or 2 trees, maybe in a hectare of forest or an acre. And so when you looked at it, as a child, you couldn't really tell that there'd been any logging. Whereas when I started in forestry, I got a job with this forest company, and they were clear cutting, right? So clear cutting from one end of a valley to another. And for me, it was absolutely shocking that this was my new profession, and I was witness to this kind of logging.
The same word I was going to use. It must have been shocking to you to see that approach. But from an early age, I gather you've had this fascination with roots and fungi and what lies beneath the forest. Now, how did that come about?
Well, I'm in the family lore. I was a famous dirt eater from the beginning. In fact, the very first
Oh my
I was a
God.
dirt eater. The first picture of me is in the sandbox with my mouth full of dirt and worms.
Oh
And so it came to me naturally. And so I had this habit of eating dirt even well into my childhood, which, I also sucked my thumb. So I had the 2 things going on, dirt eating and sucking my thumb, until I was 12, by the way. I was quite a shy kid, but I found solace in the woods and in the soil. And then one day there was this event where our beagle dog got trapped, and he fell in the outhouse near the loggers' houseboat that we were staying on this summer. And, my whole family had to go in and dig jigs out of the outhouse. And I just became so fascinated with the mushrooms and the roots and the soil. And I just thought, this is me.
You did say the outhouse, didn't you?
Yes.
And
Yeah.
poor Jigs is down in
Jigs was
a
a
hole.
curious dog, and he was always getting in trouble. And this was like, it was, none of us were kind of surprised, but we all rushed up to, and the digging and the axes and the digging him out of this deep, deep outhouse hole. And he was baying away, but eventually we rescued him.
And who gave him the bath afterwards?
Well, that was me, because I didn't mind that he was covered in dirt and all this other stuff too.
And so you really became fascinated with everything that you realized was down there.
I did, yeah, yeah. Yes, including the mushrooms. And so my grandfather was especially interested in mushroom because he was Quebecois, French. He was mushrooms were a big deal, and so I became fascinated with them too. And yeah, anyway, this really rooted in me, literally, this complexity of this world below ground, but also, just the forest itself. It was to me, it was this a place of connection, right? It was where you just go in that forest and you're part of that forest. You are entwined with the roots and the crowns of the trees and all the species. It's a place of home. It was for me.
So working in this logging company had to not only have been such a shock, but taking you away from your interest really in the trees themselves. If you're clear cutting, you're just getting rid of the trees.
Mm-hmm. Yeah, but so I started in the 1980s, early, like right at 1980 as my first job in the industry. And so that was really just near the beginning of clear cut harvesting in Western Canada. And so there weren't a lot of these clear cuts, but I always felt like I grew up in a province of old growth forests. It's now a province of clear cuts because it's been so extensive. It's going on even today, and there's all kinds, like there's actually protests going on for our last little bits of old growth that are left. It's just like it's been heartbreaking to watch. I call it grief, to watch our forests get cut down like that. But I'm also very active in trying to bring awareness to people so that we can help save what we do have left and try to regrow some of these beautiful old forests.
Now, the balance there between the clear cutting for profit and saving the forest
Mm-hmm.
for what they can tell us, what we learn from them. It's a tough balance, but money wins out, doesn't it?
We've let that happen, right? Like we've I think what happened is, it seems so endless, the beautiful forests when colonization happened of North America. Europeans arrived on the shores of the United States and Canada, now called those, and just moved from the East Coast to the West Coast, cutting down forests. I think there's, it's a utilitarian and there's a lot of value in the forest. There's also fear of forests, psychological fear of forests played a role in that. But yeah, and then it's become just this huge, multinational corporate money-making business, not just in North America, but around the world. And valuing forests just by these simple products like 2x4s and pulp and paper, when in fact these forests, they cover a third of our earth, of our land on earth, and they're the source of biodiversity. They're the source of, they store 85% of our carbon. They clean our air, they clean our water. They're absolutely essential. We depend on them for our lives, and yet we haven't valued them in that way. We've had this very, very narrow view and valuing of just these products, and that has to change in order to save these forests.
So, in your early years working in a man's world, truly, what was that like for you? How were you treated when perhaps you thought or even said out loud, why do
Mhm.
we have to do this?
It was when I started out, I was so grateful to even be allowed to work in the forest that I just kept it to myself. But definitely it was a man's world. Back then in the 1980s, being the only girl in what we called a woodlands office. And the men would have their pinup girls on the walls and they were laughing. I mean, it was very much like a boy or a man's locker room. And to squeeze into that and just sort of be quiet, to not be obtrusive and be, and try to belong. It was very difficult. And even I think they had a hard time accepting girls as well, because it was their world. And to suddenly have a girl in there, it was like, well, how do I deal with this female? And so it was difficult on their side too. And it's taken decades really for women to slowly get into the field, but we have. And you know, it's important because, as we'll talk about, I'm sure, is that how men view forests is quite different than how women view forests, or at least when women start looking at forests, they see other things that the men have not, or that they have not historically, you know, recognized. And I always liken it to, you know, it's like when you just have one gendered view of a forest, it's like you can only see out of one eye. And when we're both genders and all people are looking, it's like we see the whole picture.
And so what do you think men see? You talked about what you think women see.
Yeah, so in my field, which I learned as I went along and got even a master's degree looking at how, you know, trees compete. And so there was so much focus on how trees compete with each other, and that, you know, and with other plants. And this whole idea that competition was really the dominant, if not only, way that forests grew up and were structured, meaning that, you know, that they emerged out of this competitive fight against each other to get as many resources for them as they possibly could to grow tall and dominate. That drove forestry practices, and still does to this very day. You know, how we plant our forests, how we weed our forests, how we space forests, you know, it's all based on this idea that only competition matters. And what I saw was that actually these trees actually have social lives. They actually have very sophisticated relationships, which includes competition, sure, but also a lot of collaboration, that they cooperate with each other. And so this way of seeing the forest, yeah, it's completely opened up, I think, for a more full holistic view of what the forest really is.
So you began observing seedlings during this period when you were working with the men. What was it about those seedlings that fascinated you so?
Well, so here we took these beautiful old growth forests, clear cut them. So all the big old trees, every tree gone or milled, and leaving these big open areas that my job as a young forester was to repopulate these clear cuts with seedlings that were brought in from a nursery, grown in a nursery. And it was all one species. So instead of like the multiple species we took out of the forest, it would be one species we put back. And they didn't do very well. You know, they didn't grow very quickly. They looked yellow. You know, we called that chlorotic. And I was always like wondering what's wrong here, you know. And eventually I would dig seedlings up, and I would see their roots were just not very, they're not full, right? They're not linking in with the soil. And really, if you think about it, you know, what drives our cycles, our big cycles on Earth is that active photosynthesis by a tree, and that energy going into the soil and fueling this whole soil food web that drives our carbon cycle, our nutrient cycles, our water cycles. And that linkage between the photosynthesis of the tree and the soil, that link was not there. And these trees were just not inhabiting the soil like they needed to.
So the trees that you were planting, were they the same as the ones that had been clear cut on the part of industry, hoping for the same kind of output that they had just cut down?
Yeah, I think that the hope was always that, well, we're going to get as much wealth out of this forest that naturally grew here that we were able to exploit basically for nothing.
Right.
And we're going to grow the same thing back. But instead of planting, you know, in some cases up to 10 species in a forest, there would be one species that we planted back. And so it would be one of the species that was there, but not the full suite of them. And so we basically reduced the diversity, the tree diversity of the forest by trying to, you know, plant it to that one species that was the most lucrative from the old growth forest, right? The one that brought the most profit. They thought, oh, if we could just plant this one tree species and just favor that one, we're going to make so much money. But what they missed out was that diversity of trees, and the diversity of plants was so important to the health of the forest. And now we're seeing the consequences of reducing that diversity.
So you figured out that these seedlings were not only not thriving, they were not surviving.
Mhm.
So where did that take you in terms of your expression of concern to the people with whom you were working?
Yeah, so I did eventually become a researcher with the Ministry of Forests. It would be like the USDA Forest Service in the US. It was, but here it's the Ministry of Forests. And my job was to figure out like how were these plantations doing? And I was observing that a lot of the trees were dying. And it turns out that they had these root diseases, so these pathogens in the soil that were killing the trees. Now today, even years later, there are still many, many things that are killing trees and forests more and more because they're getting more and more stressed with climate change. But back then it was this root disease. And so I became interested in what's going on below ground. Why is this disease flourishing when it used to be in balance, right? I mean, those pathogens were always there, but here they're becoming stronger, more virulent, they're more destructive. And so I went back and did my PhD and I looked at, what were the other fungi in the forest? What was out of balance? And I discovered that they also form these other kinds of associations with a helper fungus called a mycorrhizal fungus, and which people had known about for quite some time.
Say that word again, if you would, please.
Yeah, it's a big mouthful. It's called mycorrhiza. So myco is the word for fungus, myco, and rhiza is the word for root. So it's like a fungus root. And it really is the relationship between this kind of fungus that's a helper fungus, which grows through the soil and brings nutrients back to the root of the tree. And the tree provides photosynthate in exchange for these nutrients. And so it's like this, we call it a mutualism where they're both benefiting from it. And it turns out these mycorrhizas, I mean, they're absolutely essential for trees all over the world to grow and reproduce. So it's what we call an obligate mutualism. And it turns out that these fungi can actually link trees together. And that's what I started studying, is what were we doing to disconnect these linkages in the forest?
And that's what was happening.
That was what was happening, yeah.
Was it because, I mean, going back to that clear-cutting experience, was it because they were trying to replant one species of tree and not a diversity that would provide this kind of interaction that you're talking about?
Yeah, that is part of the explanation. So, every tree is a host to many species of these mycorrhizal fungi. And as they get older and older, these trees, they take on more and more of these relationships. Douglas fir alone can associate with thousands of fungal species in the soil. And these fungi have different jobs. It's like in our own societies, human societies, we all have different jobs, right? I'm a scientist, you're a writer and a radio host, and we have our jobs, right? Same thing in the soil, right? All these fungi have different jobs. They get nutrients from different places, like maybe different depths of the soil profile or different kinds of nutrients, but they all do something. And so when you reduce this diversity of trees, you actually reduce the diversity of fungi as well. And also following clear-cut harvesting, the diversity just goes down naturally because the old trees are gone. And the older the trees, the more diverse the fungal network is. So really what we're doing is ramping down the functioning of the forest and that association when we clear cut and then plant to one species.
So what fascinates me is that you are saying that these trees, through this kind of network, are actually communicating with each other. How can you explain that to us?
Yeah, so these fungi, they link trees together. And so these linkages, you can think of them like telephone lines almost, or you could think of them like the internet. And so these trees then are able to communicate with each other through these fungal linkages, these telephone lines of fungi. And the way they do it in many, many ways. They have a very sophisticated language. What I started first looking at was, as a forester trying to fit within the man's world of thinking that trees only compete for resources, I looked at resources first. So resources are just those essential things that trees need and plants need to grow. And that is light, water, and nutrients. And so I started to look at, carbon, which is what is fixed through photosynthesis. So carbohydrates and sugars, how are they moving through the network? And is nitrogen, which is also like an essential limiting nutrient in forests, how does water move through it? Turns out they all move back and forth between these trees through these telephone lines and these fungal lines through the forest. So that's one way that they communicate. They also communicate other information, which is, we still don't completely understand that, but they also communicate whether they're stressed out or whether they're healthy, whether they're full of nitrogen, whether they're depleted in nitrogen, and they'll shift their resources around according to who's got some and who's got not enough. And so there's this balance going on. They also communicate their identity, right? Like you'll say, I'm Diane, I say, I'm Suzanne. Well, they also can identify each other, not by name, but by species and their relation to each other. So it's quite fascinating and very, very sophisticated.
So when you first came up with this research, how was it received?
Well, it was been a bit of a rocky road. So, keeping in mind, I was like 32 when I made these discoveries. And now I'm 60, and it's been, up and down the whole time. But early on, when I was a young woman, young scientist, I felt like I'd stepped into a hornet's nest, to be honest, because when I published my work in Nature, there was a lot of conflict around that. So there was, first of all, the foresters, the people that were making policies and that were driving forest practices, they didn't want to hear about this. In fact, they tried to keep me quiet. And in fact, I ended up leaving the Forest Service and going into academia because it got so rough. And then on the academic side, people were really resistant to the idea that plants could collaborate. Like, they were so fixated on competition, which really came out of, Darwinian theory of evolution that was applied to ecology. And it's like, we're not going to hear any of this other collaborative stuff. And so there was a lot of resistance on the academic side. And so, yeah, it was pretty rough at first.
So you're saying they were sticking to Darwin's theory of competition and the strongest wins out. And you're talking about a kind of collaboration going on among trees. When in a situation where a tree is not doing well, how does that tree then communicate its need, and what happens then?
Yeah, it's so fascinating. So trees are able to communicate this, whether they're being, fed upon or attacked by an insect or a pathogen, or burning up, or if they're stressed by drought or any kind of stress. They're able to communicate that with their neighbors, both through the air and through the soil. And so, of course, I study this communication through the soil, but researchers in California and Washington prior to me had figured out that plants in agricultural systems actually communicate with each other about these dangers, these basically infestations with each other, and their neighbors were then able to defend themselves against that. So what I did is I thought, is this going on below ground between trees as well? And did some work with a scientist in China, Yan Song, who had started working with tomato plants and understanding that this communication about herbivory was going on between tomato plants through these mycorrhizal networks, linking them in the soil. And so she came over and worked with me, and we discovered that, yeah, when trees in our forests are attacked by like mountain pine beetle or a pathogen like armillaria root disease, that those trees then communicate with their neighbors that they're under distress, and that the neighbors then pick up that message, they upregulate their genes, and they start producing defense enzymes that protects them against that herbivore or that pathogen, and they're able to survive better.
And what about the tree that's communicating is under attack?
Well, that tree is trying to defend itself as well. So it goes through this whole biochemical stress response. It's like, if somebody were to shout at you, you would have like this reaction, right? Or if somebody were to, jump on you, you would have this emotional reaction. Well, trees have a bunch of biochemical reactions. They go through these cascades, their defense cycles, their cycles get activated. So there's a jasmonic pathway where a bunch of chemicals are activated. And so they try to defend themselves, especially in their root systems. And sometimes they make it and sometimes they don't. And if they don't, one thing that we found out is that trees not only send these defense signals, but they start shoveling their energy, their carbon through the network to the surviving neighbors around them to to allow that energy to be, saved within the ecosystem instead of just going up into the atmosphere.
Can you give us an absolute example of where you've seen this happen?
Well, so I started working in our forest in British Columbia thinking about climate change. So this is what was my motivating factor for this experiment that led me to these conclusions. So as climate changes, we're expecting, or we're predicting that some trees are going to start to die back at lower elevations, and then the other trees that are more adapted to drought, because it's supposed to get drier and hotter, that they'll start replacing those trees that are dying back. So I worked with those. I worked with Douglas fir and ponderosa pine, and Douglas fir was getting attacked by western spruce budworm at the time, which is amplifying because it's getting warmer. The cycles of the insects are speeding up. The trees are stressed out. And so there's a lot of mortality going on. And so I wanted to know if these Douglas firs were communicating with the incoming ponderosa pines. And so I grew them together in the greenhouse, linked together by these mycorrhizal networks, and I would attack the Douglas fir with this western spruce budworm, which is proliferating across our landscape naturally. And sure enough, the Douglas fir sent its signals to the ponderosa pine. That ponderosa pine upregulated its defense and produced these enzymes that protected it. And so that's where I first learned about this or discovered this. And since then, I've gone on to study with my grad students the mountain pine beetle and how it affects lodgepole pine, which of course has killed 40 million hectares of pine forests across all of North America. And it turns out that these defense signals not only happen between the trees, but they actually get carried on through generation after generation, that the seedlings actually learn through their biochemistry to be more resistant to the beetle going forward. So it's absolutely fascinating that this information is actually, transmitted not just between trees, but from generation to generation.
Now, we do have a number of questions, but before we get to the first, would you explain to us the mother tree?
Yeah, so the mother tree. So one thing that we wanted to do is, we talked earlier about all the controversy that these studies generated, and the science got stuck in what do these networks look like, because they're hard to see, right? And so I thought, we're going to map what this network looks like in the forest. So I got a graduate student, Kevin Byler, and we went into this Douglas fir forest with trees of all ages, big old trees and little trees growing up underneath. And we mapped one of the species of 100 in that forest. And we mapped where all the trees were and where all the linkages between the trees were of this fungus. And we found out that everything was connected to everything else. But the most highly connected trees were the great big old trees. So the bigger and older the tree was, the most highly connected to all the other trees. So you think of, they were called hubs, right? They're the hubs of this big network. And the reason that they're the hubs is because they have huge root systems. They're host to many, many species of fungi. And they have these huge crowns where they fix a lot of carbon, and that energy goes into the root systems and it moves through the forest. And so it turns out that energy and seedlings that are establishing in that network benefit from that. And they benefit not just from, carbon moving from old trees to young trees, but also from just linking into that network of that huge uptake capacity. It's like, your grandchildren or your children learning your great wisdom that you learned from your mom and your grandmother and so on. It gets carried on and it supports the new generations. And so, in graph theory, in neural networks, they're called hubs, these big, because these systems are, you see them ubiquitously across nature, these networks that are designed this way with big hubs. But the fact that these trees were nurturing the young generations led us to calling them mother trees because of that nurturing capability. And I thought that would be easy for people to understand and remember.
Yeah. A while back, people were saying, well, there was a book out saying you need to talk with your plants because that will make them grow stronger and healthier. But you're saying that the mother tree herself is the one doing the talking,
Yeah, well, the most talking.
the most talking.
Yeah.
Yeah,
They're all communicating with each other,
yeah.
whether it's a small tree or big tree, or intermediate, a teenager, a young adult, they're all communicating. But these big old matriarchs, if we want to call them that, they're the linchpins. There's what keep the whole forest together.
But then what happens when somebody comes along and cuts that mother tree down?
Yeah, that's a great question, because that is exactly what we do, right? When we clear cut, we're especially going after the big old trees because they're the most profitable. And so we've studied that. So there's a bunch of things that happen. So that big old, when they're cut down, of course, that tree will be sending defense signals to its neighbors to try to tell them, hey, there's danger here. And they also will send their carbon into the surrounding trees, like I said. And in the meantime, if the whole forest is cut down, and if it's and one of the things that we do too is we tend to spray herbicides on the native plants that are still there, because we think if we plant our seedlings into these, sort of like these agricultural fields, that they'll grow faster, they'll have all these resources. Well, it turns out these native plants are important for hosting some of these fungi. And if they're gone too, we basically lose the fungal network.
Wow.
It dies off within a couple of years. So it's actually essential that we get trees and plants back in there, or even better, if you're going to cut, leave a bunch of trees, because they'll maintain that network and it will reorganize itself. So it's kind of reshapes how we think about how to harvest forests, right? We need to leave some of these big old trees behind.
Here's a question for you. Does Dr. Simard think we should turn any remaining North American old growth forests into national parks? He goes on to say, I think the only old growth forest in the U.S. is the Shenandoah, where Richard Power, the author of The Overstory, lives.
That's such a great question. And we have pushed our forests to such an extent that we've pushed it to the point of collapse through all this commercial harvesting. And so we're at this critical lifeboat question. What do we do now? Because we're losing so many. Clear cutting is the cause of most of our species extinctions. It's the cause of about a quarter of our climate or our greenhouse gas emissions. Without trees, our greenhouse gases will go through the roof. So what do we do? We're at a crisis point. And so I actually agree that if we can, any remaining old growth forests, which are huge storehouses for carbon and biodiversity, especially the West Coast forests, the Amazon forests, the boreal forests, those really productive forests should be saved. They should be put in reserves. And yes, some of them will burn or some will die, but then, we can cultivate them so that they recover quickly. We can cultivate old growthness through very clever or very smart science-based approaches that we know about. And so that means focusing, if we're going to harvest, we do need to harvest some trees to build our houses and so on. We need wood, but we can focus that on the forests that have already been cut in the past, where the losses have already occurred. And so we don't actually accelerate the loss, right? So I would say, yeah, if you have old growth forests along, in these really productive areas, they should be set aside.
Here's another question. Do you believe reforestation should avoid non-native trees?
Yeah, I mean, yes, I do. I think that, so that question, so what's a non-native tree? So the species, we always try in forestry to at least have the native species to reforest the areas. And that is, that's been kind of become a standard practice, I would say, across North America. But, as climate changes, the thing is that species are not going to be able to keep up with the velocity of climate change. They're not going to be able to migrate as quickly as they need to. Historically, the paleoecology records show that they migrate maybe 1 or 2 meters a year. We need them to migrate 1,000 meters a year, right? In order to keep up with climate change. So what are their choices? They can adapt, stay in the same spot and adapt, but they can't adapt that fast. And so what our job then as human beings now, we have really no choice left, but we're going to have to help these trees migrate. So that means moving genotypes. So not changing the species necessarily, but the genotype. So the genetic variability associated with trees that maybe grew up in a warmer climate, we need to migrate them to cooler climates that are going to be warmer, in the near future. And so we're actually doing that actively in Canada, and I'm experimenting it with my own experiments, how to migrate seedlings in the environment where old trees are left behind, because those old trees will bring those new migrants along. They will shelter them, they'll provide resources, they'll help them out. But if we move them into like big open football fields with no other trees, they're not going to do so well. So we have to have a very sophisticated and attuned and locally based approach where we really know what we're doing.
But are there instances where you see the mother tree actually rejecting a species that's been planted nearby?
Yeah, that's a really great question. So for sure, there's been a lot of, I don't do this science directly myself, but there are, trees can actually load up on pathogens over time, right? They can become diseased. And so then mother trees can actually, or trees can actually create more elbow room, or they can actually, try to inhibit even their own offspring if it's not a safe environment for them, or they can favor other trees to compete or to dominate over ones that are not well suited. We see these patterns, and so I mean, there is a mechanism in there for trees to, or forests to change as according as you say. Yeah, I don't understand it super well, but yes, that happens.
Here's a question that came in before the program saying, we're big fans of Dr. Simard's work as landscape architects. We're interested in how her findings about forest mutualism will impact horticultural and planting design in the coming years. Can Dr. Simard speak to this, and does she know of any similar work being done on mid-Atlantic forests?
I'm sure people are working, I know that there are researchers in the Atlantic provinces and the East Coast that are working on networks and understanding how trees are linked and communicate in these Eastern provinces. I don't do that work myself. I don't think people are making strong headways with it. You really have to have, there's certain labs around the world that really start to specialize in those. And I don't know of a particular lab in the East that does it, but these concepts still apply. It's still, these phenomena still occur in those places. So yeah, and I can't remember the other part of the question.
The mutualism.
Oh yes. Right, in the horticulture. So yeah, even in like orchards or in urban environments, all of these trees form these fungal, these mycorrhizas. And they also, if they have the opportunity, they'll form networks with other trees if they're compatible. And so the trick here is, when you're planting trees in urban environments or horticulture settings, is to make sure the soil is good, right? There's nothing like living soil. And I say that because I know in a lot of urban environments, trees are planted in horrific soils, right? It'll be fill that's brought up from some deep in some foundation that is like, doesn't have living organisms in it. So it really needs to be good soil. And then the trees can connect with the soil and also provide them the opportunity to connect with each other, which means growing them in clusters instead of alone, right? And growing them with other species that are companion species so that they're more of a community rather than isolated.
Here's a question how do you physically detect and see these fungal networks?
Yeah, so depending on the kind of forest you're in, you can even go in, especially in high elevation forests or northern forests, you can roll back the forest floor, which is just that covering on top of the soil, that organic material, and you can actually see the threads in the soil, these white and yellow threads. That's the fungal network. Some of them are pathogens, some of them are saprotrophs, but a lot of them are the mycorrhizal networks. So you can do that just as a layperson, but the way we do it is we actually use DNA techniques. We actually sample the roots of the trees, we sample the soils, and we do what's called polymerase chain reaction to amplify the DNA, just like we do with the, detecting COVID in our noses, right? They use the same technique. We do that for fungi too. And then we identify what they are. Yeah.
And here is another question. How can forest stewardship be incorporated into our culture, including neighbors helping neighbors care for local forest patches as a beginning step? And I have a very sad story to tell you. We lived nearby in a home for 40 years, and in the front garden was a 100-year-old beech tree, beneath which no grass would grow. No matter what we tried, no grass would grow. So we finally gave up on it. When we sold the house, sadly, I went by a few months later, and that tree was taken down. And it broke my heart.
I bet, yeah.
Because it provided the most gorgeous shade. It was the prettiest tree on the block, and now it's gone for the sake of growing grass. And you begin to wonder what it is that people forget in regard to trees, thinking instead about growing grass.
Yeah, I know. It's a cultural thing. Some people are afraid of trees, but I think, and then we get enamored with this perfect lawn when in fact that perfect lawn is a desert, right? I was actually talking with Cy Montgomery the other day and she was talking about hummingbirds, how hummingbirds, we think of them as feeding in hummingbird, nectar, but actually their main food source are bugs that live in the soil. And if you grow grass and then apply pesticides, those bugs are gone. And so gone are the hummingbirds. So I think it's just lack of education, right? If people and lack of education, and then just being removed from the environment and living our lives in cities and towns and not ever really going, or in apartments and not having the opportunity maybe to go out into the forest. But it's absolutely essential to go out, be with these trees, sit against the tree and just be with it, and then you'll start to love that tree like you loved your beech tree. And probably the people who bought the house didn't take the time to do that, but we all need to do that. And only when our hearts are melded with the heartwood of those trees will we actually start to love them and care for them. And that's why it's essential we all reconnect with nature.
So it sounds as though you've just answered the question from our viewer: how can forest stewardship be incorporated? You're saying learn to love the trees.
Yeah. And, to know your local forest, right? Like, I think one of the mistakes that we made when we colonized North America is we didn't learn anything about the forest. We took the European practices of what was developed that worked in Europe for those forests, and we said, okay, we're going to just do that in North America without actually learning about the forest. And in fact, it's gotten worse and worse that we know less and less about our forests. There's fewer and fewer foresters or people on the landscape actually watching how things change, the variability, and we apply, I call it the Mcdonald's approach to forestry. It's the same thing everywhere because we're not paying attention to local conditions. And the only way you can know about that is to be out there and and if you're not going to be out there, invest that, that opportunity for someone else to do it. Like, let's fund people to go out and look after our forests so that other people can maybe look after the sick patients in hospitals, but we need to invest in stewardship and caring for our and fulfilling our obligations to future generations to look after this place that's our home.
California's fire season has just begun, and we have a question here. The Yellowstone fire seemed to revolutionize the way we view fire and forests, and the issue of important rejuvenation. Can you comment?
Yes, so this is a tough question, but our forests for generally across North America and many forests around the world are fire regenerated forests. So when you get into wetter ecosystems, the fire becomes less frequent. Drier, hotter ecosystems, it's more frequent. So there are distinct fire regimes. What we've done in the past is we've suppressed fire. And the reasons fire suppression happened is because we thought, oh, we'll save those forests, we can make money from them instead of them burning down. And so we got better and better at suppressing fire without understanding that these forests needed fire. And fuel levels built up, and that created, as climate changed, we had the perfect storm with high fuel loads, hot temperatures, and boom, we get these big fires. And so what we really need to do is we need to reintroduce fire into these landscapes so that the forests become healthy again, because they're adapted to that, right? They rejuvenate following fires, but not these extensive, huge mega fires that are so severe because that we've created this extreme situation. So we have to be really, really careful in that we have to, I think doing prescribed burning where we're controlling, how far these fires get away on us, or if they do. And then of course, if there's urban environments around, we need to protect those. So we have to be really smart about it, but there is a path forward, right? And that is reintroduce these natural processes so that we can reinvigorate the forest so they can defend themselves.
Here's a personal question for you, Dr. Simard. Can you talk about your experience with breast cancer and how it influenced your work? The person who's listening says, I found that part of the book very moving.
Oh, yeah. It was traumatic for me. Of course, it is for any woman or anybody who gets sick with a life-threatening disease. And it really did move me to, my kids were young, 12 and 14 at the time. And I thought, because my cancer was advanced enough that it was, I could die, right? And so I thought, I really need to focus my energy at this point on my children, but also how can I learn from the forest to heal myself? And what can I learn and what can I give back to the forest? And so it kind of changed my direction of research a little bit, in that I started looking at what happens when trees are dying. What messages are they sending to their offspring? Do they, and are they helping their kids or their offspring to prepare for the future? And so I found out that they are doing that. And that work was driven by my own experience of trying to understand, what do I do? What do I do to help my children through this and help myself as well? And so my sickness informed my research. What I found out from the trees informed me. I learned that trees and forests are meant to heal. They're wired for healing through their networks, their communication with each other, their ability to bond together. And I found a group of breast cancer comrades. We call ourselves the Breastless Friends Forever. And the four of us are a tight group, and we're all alive. We're all healthy. I mean, I'm not saying that this is a miracle cure, but going through chemotherapy together, which we all needed, we've survived. And I also am doing research with new students on understanding the yew tree, which is what produces some of the medicine that I took to cure my breast cancer, paclitaxel. Yeah, so now I'm doing research with my grad students where we're looking at networks between yew trees and cedars and maples and determining if the community of trees, the species identity, how close they are, how much they're networked. Does it influence the amount of taxol that the yew tree produces? And so we're just at the beginning stages of this, but I suspect they are. We know that they're all connected below ground and communicating with each other. We know that already. And so now we're looking at the taxol production in the yew tree to see how much it's influenced by whether they're connected or not, what's the identity of their neighbor. And the yew tree, by the way, produces taxol as a defense enzyme itself. It's a defense chemical for the yew tree for when it gets infected. And so it's just a natural, I don't know, it's like, it's a natural question, I think, and I wanted to give back to the forest as it saved me. So,
do trees have feelings?
you know, that's such a good question. I don't know. I mean, okay, so let me approach it this way. Feelings is a word that we use for human beings, right? We know that trees are perceptive of each other. We know they respond to each other. We know they're attuned to each other. We know they have immediate responses if they're stressed out. Is that feeling? Well, it's definitely a biochemical response that's immediate, right? We call that in humans feelings. If I use the word feelings for trees, I'll get all kinds of people saying, you can't do that. That's called anthropomorphizing. You know, and so that's why I'm skirting around your question, because I think we need better words for this. And actually, I will say, you know, in the ancient languages of Aboriginal people all around the world who understand these phenomena much better than Western science has, which has tried to dissect things into their parts and miss the connections often, that our Aboriginal roots of all people have understood this, and they have had words for it, and they don't really exist in the English language. And so I'm hesitant to use that word, even though I say there are huge indications that they have similar responses.
But do you think that they sense our presence?
I think so. Yeah. I mean, it's so funny. I'm trying to do some research on that, and I didn't get funded. My grant didn't get funded, and I think it's because there's still this huge, mental block that we still think of trees as, or plants as these inanimate objects that have, that don't have perceptions of us. But we know, based on our experiments so far, if I go in and pluck the needles off of a tree, it immediately has a response. We can measure it. We measure it in their enzymes. We measure it, in their stress levels. We can, immediately. Well, of course, that's a sense that I did something to that tree. So does that answer your question? I think so.
Suzanne Simard, this book is really glorious.
Thank you.
It makes us all think so much, not just about trees, but about nature itself and the important role that trees play in our lives. I thank you so, so much for being with us. It's called Finding the Mother Tree, Discovering the Wisdom of the Forest by Suzanne Simard. Thank you so very, very much.
Thank you, Diane. Those were lovely questions. That was really fun to talk to you.
Thank you. Great to talk with you. And I want to say thanks to all of our guests today. And before you go, please do take a minute to fill out a short survey about this event. It's going to pop up on the screen, and if you would consider donating to WAMU, it's your financial support that makes it possible for us to bring you events like this one. Go to dianerehm.org/give. Our next book club meeting will be on Wednesday, June 23rd. I'll be discussing Clara and the Sun by Nobel Prize winning author Kazuo Ishiguro with a group of panelists. So stay tuned to your email for further information. about that. Our book clubs are produced by Rebecca Kaufman and Allison Brody. Rashad Young is our engineer today. Yanling Zhang is our events coordinator. And we couldn't do this event or any of our book clubs without the help and support of Julia Slattery, Melissa Glass, Lynn Kronberger, Brian Colombo, Verendra Silver, and Michelle Morgan. A very special thanks to all those folks and to you as well. Thanks for being with us. I'll see you in June.